In production, trusting the output of your agentic AI system blindly is one of the biggest mistakes. If quality is more important for you, before sending the output to the user, it is very important to verify that the output matches the quality standard that you desire. So that's where, if quality is more important for you, then this reflection design pattern is the go-to pattern that for your use case. So basically, in this case, the agent plays dual role of both generator and critic. That means it will self-evaluates its output before sending the output to the final end users. So that's what we will talk about this design pattern in this video. So we'll talk about the core underlying architecture and the core idea of the design, when to use, when not to use, the limitation, trade-offs, and also most importantly, we will see how in the bioinformatics field different use cases this agentic design pattern will fit. And most importantly, we will do hands-on where I will show you how to practically build this kind of design pattern. So without any delay further, so let's talk about the design pattern. So as the name says, the generator, critic, or reflection or self-reflection. So basically here, given a task, the agent will first generate the initial output. Then the agent will switch its role to a critic. So now it will evaluate the quality of the output and check whether it meets some standard or not. If it yes, then it will give the final output. If not, it will revise it will provide some feedback, and that feedback will go back again, and again it switches role to this generator, and it will incorporate the feedback to generate the output, and again this cycle continues. Okay, so that's how the same agent will behave, two kind of role, whether generator and critic kind of role. Okay, this is the design pattern. So how the pattern works? So basically the same loop side, generator to critic to revise loop. So this is the most important phase. Once we get the output from the generator, the critic will evaluate whether the output is accurate or its factual correctness, or maybe you have defined certain constraint or certain rules. So this critic will now check whether those rules are satisfied or not, whether those constraints are satisfied or not, those kind of thing, and whether some logical gaps or inconsistencies are there or not. So this is what the criteria of evaluation of the output from the generator. So if the issue is found in the criteria phase, means critic phase, then the output will be revised and the reflection cycle repeats. And it's very important to define a correct exit criteria. Otherwise, it will continuously it will that infinity times it might go. So that's where either the exit criteria is whether the agent says that okay, now I am satisfied with the output, so let me send the output. Otherwise, we can say that after 5 tries you just exit. So that here is the hard limit. We are saying that okay, you try for 5 times. If not, you can go out. So that kind of exit criteria is important here. And the main advantage is that the role separation, because this is the very important, right? Reflection improves quality. This applies to us also, right? Whenever something happens, we step back and we reflect, then we improve ourselves. So the same thing happens with the agents as well. So the generator focuses on just producing the output, whereas the critic focuses on the evaluating. That way, we are separating or reducing the confirmation bias. And we are forcing the agent to step back rather than the defend its first answer. This is very important terminology called step back. So that's why this kind of design pattern is also called a step back. So before sending the output, jumping directly to the user, it will go back and step back, right? So when should we use? The best scenario is like when your output quality is very, very important than speed. You are not worried about how fast you want to give the response. You are very sure that whatever your output is generated, those are high quality, and the errors means very, very significant consequence. You want to avoid any errors, and these are the cases you should go for this reflection design pattern. Some example would be, let's say, code generation with security and compliance is there, or maybe some financial or scientific analysis where mistakes are very costly. That's where we will go with this kind of design pattern. But limitation is what? Because it's reflecting in the trade cycle rate. That's what increase the token usage, so cost is high, and again latency, because it will not complete very fast, because if the loop takes more time, so you will get a delayed output, and risk of unnecessary looping. So that's where the common pitfalls are the very vague criteria. So you say that to the critic that check if this is good or not. This is a very vague statement where agent will not clearly, it is very subjective, right? So you have to objectively define what is the criteria by which this critic will evaluate your output. So that's what we need to, very, very poorly defined reflection criteria will waste the compute without improving any outcome. So if you are going with this kind of design pattern, very, very important to define the critic, like how you will going to evaluate it. And so main is like the rule of thumb is like when cost of mistakes is very, very high, then cost of extra compute. You are okay with extra compute, but you don't want to make any mistake, then you go kind of this kind of design pattern. Okay. So some example of bioinformatics use case is most importantly variant interpretation summary, because nowadays we are generating clinical report, it consumed by the patients, so there you do not want any mistakes. That's what clinical and regulatory report, or maybe you are doing some scientific literature, doing some reviews and doing some analysis by the agent. So you want to make sure that whatever the factual information you collected by the agent is actually correct, it's not something hallucinating, those kind of thing. And some that's what, for example, manuscript or text refinement, those kind of things. So where something subjectivity is there and where more reflection is needed, this kind of use case we can go with. Okay, so before doing that, so that's all about this case. So we will do now the hands-on, where I will show you how to build this kind of reflection design pattern. Okay, so let's go to my Visual Studio. So okay, so I will be again using the same OpenAI framework to build, and if I'm not don't know how to build, then I have, as I said, I have another video that you can watch to how to build system. Very simple, but still I will go through. Okay, so first we'll load all the libraries. So we need from this agents, OpenAI agents, we are importing these one, and also we are loading the environment where I have stored my key. So now in this use case, let's say we have two agents. Okay, the first agent, that's what the first agent called, let's say, summarizer agent. So let's call this bio summarizer, and we give him the instruction like summarize the given biomedical abstract in 50 words or less. So we'll give some text, it will just summarize in few words. Now whatever the summary we get from that, we have a reviewer agent. So now we'll consider the same agent. Now we will switch it to a reviewer. That's what we have given now, a different instruction, because building agent is same. So the instruction will tell what that agent is. So here the instruction was that you are a summarizer. Here the instruction is you are a reviewer. That's where the agent will switch the role. So through instruction we can change the agent role. So here I'm telling that review the provided summary of the biomedical abstract, and if the summary is accurate, concise, and covers the main biomedical point, and it is clearly about biomedicine, then you reply accepted. That means we are saying that okay, this is a good quality, let's go ahead with that. If the summary is not about biomedical topic or something missing this and this, then you say rejected, and stating briefly why it failed, because in less than 15 or less. But again, I'm explicitly stating that 15 or less, so that we'll consume less token. And we'll be using same LLM model. But in this case, one more thing, you can use, let's say, GPT model for summarizer, and any other model for critic as well. So you can mix and match the different LLM models for this use case. But here we'll go with the same LLM model for both the keys. So let's define our two agent. So now this is the pipeline. Okay, very simple. We are defining a very simple Python function, and it's a async Python function. And here we are giving an abstract which we will evaluate, and we are trying a maximum of 3 attempts, so that beyond third, fourth cycle it will come out of the loop, and it will come out. They will not want to go for infinity loop. So this is where we are doing a loop, for loop 3 times. It will like first, second, third. And here just to for API, I don't want to hit an API, that's why I'm just pausing for 30 seconds here. Okay, so first let's call the first agent, which is the generator. So I'm calling runner.run. I'm passing the agent here, and I'm sending the query or the text, and we will get the output over here. So that's what I'm just printing what output it got here. Now the output goes to the second agent. Now second agent will now take the abstract, that means the query, and what summary we got from the first agent. So we are just joining them, that means abstract, the query, and how the output we got, these two. And here I'm calling now the second agent, the reviewer agent, and I'm passing this prompt. And again, now this will now the reviewer will now review the output, or the critic will now review the output, and we will get the output. So two-step process. So critic, generate in critic. So now here we are checking from the output of the critic, if accepted word is there, that means it is accepted. And here we are simply returning the output to the end user. Else we are saying that summary rejected and revising. So now it will go second time and it will do it. So that means we are giving second chance to the agent to generate the output, and then we will again revise this. Now again it might happen that second time fail, it will try to third time, and if it doesn't work, then will come out, and then finally we say that fail to generate an acceptable summary after several attempts, and we will exit the loop. Okay, this is what the function is all about. So we have defined the function. So now let's first play with a very past example where we will actually pass some biomedical text so that it will pass. In the second example, we will pass something finance related where it will not pass even after 3 times. So let's first go with a past example. So here I am giving a text with trace. This is the trace under which whatever the things happen, this will be traced under this thread. So this is the query we are giving, BRCA1 TP53 cell regulation tumor suppression. So the summarizer will summarize, then critic will evaluate, and finally we'll get the output. So let's run it. Now this will now run in the OpenAI, right? So we'll go there and see how the logs. Okay, so I'm going there. This is the traces on OpenAI platform. We'll go to logs and go to the traces here, and let me refresh this. Okay, so yeah, so this is going on. So what I'll do, I'll just pause my video because it may take some time to generate the response. So let it generate, I'll come back, then we will see how the traces looks like. Okay, so let me pause the video for a while. Okay, so this completed. So if you see first the pipeline, it calls the Biosummarizer agent. So this is the OpenAI response API it's called. So this system prompt, here we have given the input, and the output what we got is the summary of this one. Okay, so it gave some summary. Now it called the summary reviewer, the second agent, which is the critic. And here you see here we have given the system prompt how it will evaluate. Now this was the query and the abstract what user gave, and this is the summary of generated by the the first agent, and now it sent the output is a accepted, and this is what we went back. So now you see the output what we got is the final summary is the what the output from the first agent is the accepted, and after accepted we are doing it, right? So now let's run this fail example. Okay, so this is the reflection pipeline fail, and I'm giving some financial question. So ideally it will fail. Okay, this is just a simulation just to see how it fails. So let it run. Again I will pause my video over here. Let's go to the traces here, the past one. So now the fail one, it will take some time to complete. So let me pause my video and then I'll resume back. Okay. Okay, so it completed actually. So let's see what happens. So first it calls the Biosummarizer agent. So here we gave the system prompt. This was the query user asked, and the summarizer summarizes this abstract. Now it goes to the critic. The critic got the input here, and critic says that it rejected, because I did not give any reason first time. So it simply say rejected because it's not a biomedical text. So now it tries second time. We're asking summarizer to let's try second time. Obviously summarizer will summarize this one, and it again now go to the critic phase. So here it is rejected, saying that not a biomedical topic, relates to finance and economics instead. Okay, third time we are again trying. So third time same output is generated, and the response now this time will be again rejected, saying that the summary is about finance, market, and not biomedicine, right? That's where if you come back here, we got attempt 1, it is rejected, attempt 2 rejected, and attempt 3 rejected, finally failed to generate any acceptable summary after several attempts. So this is how we can design a system where we have a output from the first agent, then before sending then it should go to pass to the second critic, and then define some criteria in how this critic will evaluate, and then based on the accept or reject criteria you can further decide how to do that. Okay, so I just gave you a very simple example by which we can design this kind of system, but again you can further empower these agents with more tools, and lot many actual real production scale system can be designed, but all follow the same design patterns. Yeah. So with that, I think this I come stop here, and so next video is a very interesting video, and that's on the planning design pattern, where agent can think, they can plan, and they can execute. So it's a very interesting use case, and I will see you in the next video. I hope you liked it. Thank you so much. Bye.